My name is William Trong, and I'm a product manager here at Nortec. And I'm here today to talk to you about humidification. So why would you want to humidify? Well, proper humidification of a building or space is an important consideration for a number of reasons. In areas occupied by a large number of people, such as schools, office buildings, or hospitals, inadequate humidification can have a negative effect on the comfort and health of the occupants. Studies have shown that proper humidification can result in a healthier environment, increased comfort and productivity, and even decreased absenteeism. If we look at this chart here, we can see that bacteria and viruses thrive in environments with extremely low or extremely high relative humidities. The optimum zone is actually between 40 and 60%. And in this zone, human exposure and the spread of bacteria and viruses is greatly reduced. Static electricity is another good reason to humidify. In applications such as printing, textiles, or manufacturing, static charges can disrupt operations and increase operational costs. Also, if there are volatile fumes present, static charges can lead to dangerous flash fires or even explosions. And finally, humidification is important if moisture stability is a requirement. Many materials and products must be kept at the right humidity level in order to prevent damage or deterioration. Now, one of the most common ways to humidify is to directly introduce steam into the ductwork of a building. This allows the humidity to be distributed to all occupants of the building while using as few humidifiers as possible. However, in doing so, you risk making a consulting engineer's worst nightmare a reality, and that's wetting of the duct. How can we avoid this? Well, Nortec's SAMI, or short absorption manifold, places a header and a series of distributor tubes directly into the ductwork. This maximizes the interaction between the steam and the air, resulting in the shortest possible absorption distances, so you no longer have to worry about wetting of the duct. So let's head down to the lab and take a closer look at how this distributor works.
Hello, I'm George, one of the design engineers. In the duct is a 3-inch spaced insulated SAMI. This SAMI comes with an adapter for pressurized steam. Notice the globe valve and actuator and the recommended strainer. Below you will see the condensate recovering system. The nozzles in this SAMI are evenly distributed throughout the duct to ensure that steam fills all corners of the duct. Looking at the cutaway of a distributor, you'll notice that the nozzles extend to roughly the center. This is meant to ensure clean steam is injected into the duct. The nozzles are also stainless steel and match the distributor tube. Being the same material, it guarantees a proper seal and it guarantees that they don't fall out. Other products on the market have opted for plastic nozzles, which can sometimes dislodge. You will notice the steam plume, its short absorption distance, and how it gently wraps around the tubes, keeping away from any of all walls.
As the number of distributor tubes increases, the absorption distance decreases due to the increased interaction between the steam and the air. However, the potential for heat transfer between the distributor and the surroundings is also increased due to the added surface area of the extra tubes. As a result, there may be higher steam losses in the form of condensate or increased airstream heating. So how can we avoid this? One method to reduce the heat transfer from the distributor to the surroundings is through the addition of insulation. However, not just any type of insulation can be used. The selected insulation must have excellent insulating properties, yet still be safe for use in a plenum. Nortec's insulation is made of 304 stainless steel, chosen for its low thermal conductivity, high corrosion resistance, and durability. This design creates a 1/4-inch air gap between the distributor and the shield. Since air exhibits its best insulating properties when it is still, the 1/4-inch air gap is optimal because it's too small for any significant natural convection currents to form. The air gap reduces the heat transfer from the distributor directly to the shield, and in turn reduces the convective heat transfer losses of the distributor. Conduction from the distributor to the shield is prevented through the use of plenum-safe synthetic foam strips. This material has high thermal resistance, negligible off-gassing, and low smoke generation in case of a fire. The shields also have a very smooth, reflective surface, which minimizes the effects of thermal radiation. So how much of a difference can the addition of insulation actually make? The losses for an uninsulated distributor can be significantly higher than for an insulated distributor. If we want to compare the two, we can define the performance in terms of humidifier output and plot the condensate losses in pounds per hour per foot length against the duct velocity. So first, let's look at the tube condensate losses. Here the data is plotted for several ambient temperatures over a range of velocities to highlight the effects of both parameters on the overall heat transfer. You can see that the condensate losses rise sharply for the uninsulated tubes as the duct velocity rises. Losses continue to rise beyond 2,500 feet per minute, indicating that the bare tubes can transfer a significant amount of heat. The insulated tubes, on the other hand, reach an apparent maximum around 1,000 feet per minute. This is due to the insulation resisting the flow of heat from the hot steam to the outer wall of the stainless steel shield. Now the header is also a source of losses. The same method can be used to compare the uninsulated and insulated headers. It is clear that the header follows similar trends as the tubes. It is worth noting that the specific losses, which are the losses per foot for the header, are considerably higher than the specific losses for the tubes. This is because the header diameter is greater than the tube diameter, so it has a much larger heat transfer area. So we always recommend insulating both the header and the tubes. So let's take a look at how much money and energy these losses are costing you. Consider a typical steam distributor installation with the following design conditions. New York JFK Airport with a total air volume of 30,000 CFM, a duct velocity of 1,000 feet per minute, a duct temperature of 55 degrees before humidification, and duct dimensions of 72 inches wide by 60 inches high. All of these conditions combine to give us a total humidification load of 125 pounds per hour. So first, we find the size and quantity of the distributor tubes required. Since the duct height is 60 inches and 12 inches must be deducted for the header height, 48-inch tubes are required. At 6-inch spacings, a total of 11 tubes will be required. We then calculate the total linear length of tube by multiplying the number of tubes by the length. From the graph shown earlier, at 55 degrees Fahrenheit and 1,000 feet per minute, uninsulated tubes would lose 0.44 pounds per hour per linear foot. By multiplying by the total length, we find the uninsulated tubes would lose 19.4 pounds per hour of condensate. Likewise, the uninsulated header would lose 0.8 pounds per hour per linear foot. Approximating the header length as the duct width, we find the uninsulated header would lose 4.8 pounds per hour of condensate. So in total, the entire distributor would lose 24.2 pounds an hour of condensate. Now applying the same calculations to the insulated distributor, we find a combined loss of 11 pounds per hour of condensate. So at full system output, uninsulated losses would represent almost 20% of the system output compared to only 9% with the insulated losses. The average humidification season lasts from late September to late April and involves roughly 2,000 hours of humidifier operation. Operational costs can be quantified in terms of operational costs required to generate the lost steam. The two main energy sources in steam generation are natural gas and electricity. In the case of natural gas, every cubic foot burned in a combustion process will generate roughly 1,000 BTUs of heat. In 2008, the average commercial price of natural gas was $11.31 per 1,000 cubic feet. In the case of electricity, a typical steam humidifier will consume roughly 0.38 kilowatts of electricity per pound of steam generated. In 2008, the average price of electricity was 12 cents per kilowatt hour. In addition to these energy charges, there are also charges for the delivery and disposal of water used in humidification. The cost advantages of the insulated distributors are clear from this example, with annual savings of hundreds of dollars in gas, or thousands of dollars in electricity, and thousands of gallons of water. Often, the additional cost of insulation can be recovered within 12 to 16 months of operation. There are many additional benefits to using stainless steel air gap insulation. The design of the shield has an aerodynamic profile, which reduces the skin friction and the aerodynamic drag. So in most flow conditions, the addition of insulation will have a negligible effect on the static pressure drop. Also, the smooth finish of the shield tends to shed dust and dirt, preventing it from accumulating. Other types of insulation, including foam wraps, can absorb dust and dirt and harbor potentially dangerous microorganisms. The stainless steel shields are also very durable and can withstand shipping, handling at the construction site, and installation into a ductwork, all while maintaining its shape and appearance. Foam and ceramic type insulations can be easily damaged during shipping and installation, causing delays and increased costs. And finally, like all SAMI components, stainless steel air gap insulation is maintenance and inspection free and designed to last the entire life of the unit. Insulated steam distributors are an attractive option for new construction or building retrofits. In today's increasingly energy conscious world, and with energy costs on the rise, they are an easy and effective way to reduce building operational costs and increase efficiency in any application. For more information, or to contact your local Nortec representative, please visit us at www.humidity.com.